Drilling fluids touch just about everything in the drilling process. We're here to deconstruct the drilling process and drilling fluid concepts to provide a deeper understanding of our industry. In each episode, we'll share information, talk to interesting people, and maybe share a few stories along the way. Welcome to the Flowline, a production of AES Drilling Fluids, brought to you by Matt Offenbacher and Justin Gauthier.
All right, welcome back, everybody. Another episode of the Flowline here with Matt Offenbacher. Matt, tell me something good, man. What's the latest?
Something good. Golly, I'm trying to think. Man, you put me on the spot. Like, trying to think of something good I haven't talked about recently. But, how about them Astros?
Right.
Yeah. But yeah, no, it's summer, right? Like,
It is.
I mean, something good. I don't know if it's good, but I'm going whitewater rafting this weekend.
And of course.
As is my outdoorsman nature, but
Wow, where are you going?
Colorado. So it's a friend's, like, he got married, but we're doing the bachelor party thing kind of after.
Yeah.
Except for it's like a fairly mixed group of people, and the person he put in charge of it is like cabin in the woods with no running water guy.
Oh, wow.
And so there's a very large gap between what my hope is for this to be and what I think his expectations are of everyone, where it's like, I don't mind the whitewater rafting and stuff, but
Yeah.
he's like, I'll raft behind you guys. I don't, and it's like, I have my own gear. And it's one of those, like, am I going to be left? Am I going to get eaten by a bear? Like, and I was in the Boy Scouts. Like, I have some, like, basic survival skills, but I also, like, don't like being this left in the dark. And it's also like, man, I'm a lot older than I was then. Like,
Yeah.
there's a lot of, anyways.
That's great.
I'm hoping to come back in one piece.
Well, I cannot wait for the next episode where we can talk about your whitewater rafting adventures and hopefully not eaten by a bear.
Yes. No.
But yeah, I would say that's something great. When's the last time you've done whitewater rafting?
I'm old enough to be able to say about 30 years ago.
No way.
Yeah.
That is great. You know what? They often say a common question that I like to ask people when I used to do a bunch more podcasting was like, when's the last time you did something for the first time? And as we get older, like the amount of things we do for the first time diminishes drastically. Like for the first 10 years of your life, everything is for the first time.
Yeah.
And then as we get older, we just do the same thing we did the day
so
before.
Jaded.
Right. And so it's like, although you've done whitewater rafting before, but I think it's good to have that sense of adventure and willingness to try it because, yeah, it'll make for a great story. Hopefully, a good rush of excitement for the day. So
Yes,
that's great, man. Which part of Colorado?
Salida. It's a rafting town. Yeah. So it looks
That's
cool.
great,
I'm
man.
Yeah.
All
I'm
right.
looking forward to it.
Well, to be continued. The saga will continue on Matt's whitewater rafting adventures.
Yes.
But for now, we're not going to talk about something nearly as exciting, depending on who you ask. I, for one, find this topic exciting. Matt, what do you say we talk about hydraulic modeling? And there's a lot of planning that goes into drilling wells, and oftentimes we get asked, and now, over the years and up until recent, the demand for just good information for better decision making only gets greater. And I think it'll continue to do so, especially as we get more sophisticated with our data collection and what we're actually able to offer. But hydraulic modeling is something that we do very well. We've got a good technical department that understands it and models it very well for customers and even just internal operations support. But a good topic and something that's super critical for drilling a well.
Yes. Yeah, it's so many different uses that we'll get into, but I think hydraulics is one of those tools that has matured considerably. It's accessible to all or most of us in some form or fashion, and it can be so insightful and helpful whether you're trying to think ahead or find out what's happening relative to what you're expecting.
Right.
So hydraulic modeling, I guess I'll start by saying, what is it?
Mm-hmm.
It's fluid properties change depending on how they're, what pressures they're under, how they're circulating. So We use that 6-speed viscometer, and we normally get those dial readings, right? Well, each one is at different shear rates. And each one of those points, viscosity changes at different shear rates for the types of fluids, many of the types of fluids we use. So understanding how the viscosity of a fluid at a very low shear rate or an area of low flow in the well, and then also understanding at a very high area of flow in the well, how thick that fluid is, how it's behaving, can tell us a ton, but we're in effect replicating the fluid behavior across the entire well all the way up to surface, so we know what our circulating pressures are and our suspension capabilities of the fluid.
Right.
This has evolved so much because I think a lot of us started out where it was like, okay, my yield point should be 1.5 times the size of the hole. Well, those are interesting rules of thumb, but now we can model this stuff pretty reliably, and our pumps are so powerful in this mix that it may not matter how thick your fluid is if you can apply enough energy to it.
Yeah.
So
The 6 reading or the yield point?
with respect to,
The 1.5 size, the whole size?
depends on who you talk to.
Interesting. Okay. I've never
Um,
heard the yield point in that. I'm more,
I
maybe
got
it's old
that.
school.
Yeah, I
Some,
got that years ago, but six also I mean 6 I've heard the same thing.
yeah. Anyway,
Yeah,
off topic, but, uh,
but it's a rule of thumb, and we can like model this stuff, and not only can we model it, but we can be pretty confident in our modeling.
right.
So, hydraulics takes us really far if we take advantage of it.
Right.
And the more you use the software, I think the more you can confidently go explain to somebody else, here's what's happening, or I'm comfortable with the situation where we can't quite get the flow rate we want, but I can tell you it's good enough based upon how this software has behaved in the past and how it worked in the field, you know.
Yeah.
So,
Well, so then how do we actually set this stuff up?
well, I mean, there's some debate on like what's the right rheological model, as you will. How's the fluid going to behave? API 13D explains all the different models.
Okay.
Overwhelmingly, if it's a viscosified fluid, it will probably fit pretty well to what's called the Herschel-Bulkley model. There are others, Bingham Plastic, Power Law, those kinds of things, but Herschel-Bulkley is pretty dang good. The big part with the model setup, though, is every number that getting it right.
Right.
And the thing is, what we're trying to do is we're trying to measure basically energy loss through friction across the system. We know the pressure at the standpipe, right? So that's as high as it's going to be, is coming straight out of the pumps.
Mhm.
And every inch that fluid goes, it loses energy, or we have a pressure loss. So if we can figure out the frictional pressure loss inside the pipe, inside your tools, going through the bit nozzles, up the annulus, eventually, if I subtract all those things, I get to surface, 0 or
Yeah.
14.7 psi if you want to argue. But you get to ambient or atmospheric conditions. So you're just subtracting those things away until you get to that point. So this is where it matters getting your tool joints right.
Yep.
This is where it matters. You can't accidentally have a stabilizer that's too large. You're going to have a huge amount of pressure loss there. It's not going to make any sense.
Yeah.
This, I guess, kind of when we try and explain to customers, this is why I nag you for the latest BHA.
Right.
And when you say, oh, just use one from another well, I get nervous because if you make decisions based off this information, I'm afraid that I won't have the right thing, but I'll be using the wrong information to tell you something.
Well, it goes back to just trying to pull information out of folks, and whether it's customers or not, sometimes even just, the mud engineer location is busy and you're trying to get information, but the less data you have, the less accurate you're going to be. And then the thing is with a lot of these programs or softwares is you can put the bare minimum, but you're going to be further away from the truth of what's actually happening downhole. And to your point, if you're making decisions based off this information and all of a sudden you, trip and pipe or do something, I don't know, lose returns, and it's like, well, your model said we could trip at X speed at this, blah, blah, blah. And so anyway, I think the gathering information piece is important. And it goes back to the good old saying is, junk in is junk out. So if you're only going to get a few data points to plug into your fancy software, chances are it's not going to be that close. Now you can get fairly close, but if you're in an area where there's tight margins on fracture gradients or just mud weight window, then yeah, don't be bothered by someone asking you for as much detail as possible because it's not fun to put all that stuff in there, and it's not. We don't do it for giggles to try and just like make it more accurate because we feel good about it. It's like we're trying to give you the best information possible.
Absolutely. Yeah. I mean, I think that's one of the big things. And these models can get even more sophisticated. So on some of our, like as we move into a place like the Western Haynesville or where it's really hot, South Texas, we have a high pressure, high temperature viscometer, so we can measure the viscosity and fluid behavior at 15,000, 20,000 psi, 400, 450 degrees. And we can basically create curves for all of that and put it in our software to make sure that the behavior is similar at those really extreme conditions.
Yep.
As we plan ahead. So up front, we might take some of those measurements, especially with a new base soil or a new mud weight. We want to make sure that we're sort of in the right neighborhood. And a lot of the newer models will let you do that. Or at the very least, they may ask for fluids at different temperatures, which can make a difference if you're working offshore or, really, really hot. Sometimes that can help a little bit. And then,
True.
you know, in that whole circle of things, you set up your model and then you can also sort of calibrate it to what you're seeing, right? So if you know a certain set of conditions and you look at the EDR and this is my standpipe pressure, does it match for the circulating rate? So you can sort of dial this thing in, and that just improves. It's like, okay, maybe my friction pressure loss is a little bit off, but the net is the same because I tweaked something, and I know I'm matching real time. My model is saying the same thing at different flow rates and that kind of thing. So I can lean on this and trust it quite a bit more.
Right.
And that really helps you say, okay, I've got my mount model set up really well. We know we're on the right track. And now we can use this however we want to kind of look ahead.
Perfect. Well, then let's kind of break down the uses of providing and using hydraulic modeling.
Yeah, I think, you've already mentioned up front, like what are the optimal properties to drill this well? And I think we get lost in a lot of like copy paste, but especially, we're getting a lot more of these questions. People drill longer laterals.
Right.
Is okay. What does a 4-miler look like versus a 3-miler? And even how far can I drill with this rig? And so, okay, well, this is the maximum pump rate I think you can get but like adjusting pipe rotation relative to circulating rates, relative to hole size, relative to ROP. And it's okay, well, you're going to have to slow down drilling, but you can make it this far and still get good hole cleaning. Those kinds of conversations where we look at sort of our technical limits. And sometimes it's even just with tools where we'll have some customers say, like, we use high flow tools. Don't worry about it. I can keep a high circulation rate. There are other times where it's like, oh, we can't rotate that fast with that tool in the hole. Rejigger your model because pipe rotation actually makes a pretty big difference on some areas of hole cleaning, and we don't have the optimal. We've got to engineer around it.
Right.
But we can do all of that before we even drill an inch. We can just start working on this stuff and understand the parameters within which we can operate and have those conversations.
Right.
As opposed to, hey, I don't think we're cleaning the hole. Oh yeah, you need to up your pipe rotation. Like, well, I can't. So, well, I guess you have to slow down, those are better conversations had before and not during.
No kidding. So with regards to like, because a lot of times when you're setting up a hydraulic model and you're using it, there are cases where it's like the numbers just don't make sense, or you're like, man, something just looks off. How do you troubleshoot stuff when you're just not quite confident in the outputs?
Well, there's two things. I think one is double check all your numbers and have a friend double check your numbers. A lot of the common places that we see the models not work, there's pressure losses across mud motors and RSS. And a lot of times they'll give you a pressure loss schedule relative to flow rate. Almost all of it is using water. Sometimes they'll use mud, but that can throw things off. So you either need to account for what fluid was used, check your ODs, check your tool joints, the number of times people get that stuff wrong,
Yeah.
fat finger, what have you. But then the other thing is, let's say you're having a problem on a rig, or you've run all these scenarios and you're not seeing the same thing at the rig, but you feel okay with your model. This is a really important time to find out what's different. And the sooner you can see what's different, it may be that you prevent a problem. It may be that you identify something early where it's like, oh man, our circulating pressure is a lot higher than I expected. This could be a wellbore stability issue. This could be we could be seeing the beginnings of a sag event.
Yeah.
Is stuff getting mixed properly? Do we leave the diesel running? Just strange things. And then, trying to understand why the model doesn't match can give you a clue as to what's different about my variables, whether it's in my well or in my computer. Something isn't the same anymore.
Right.
And if I can find out what, and it happens to be at the rig, it may save me some trouble, or allow me to be able to explain what I think is happening.
Right.
And you can go through different scenarios. You can start changing those numbers and say, okay, if we do this, does the hydraulic model respond in kind? And then I think on the other thing on sort of the troubleshooting and challenges is, we get this all the time where we don't know the frac gradient, or somebody doesn't believe what the frac gradient is. Like, okay, well, let's run the hydraulics and see what the ECD is before we had losses. And if we lower our flow rate to this, we don't have losses. Well, let's do some math, because the ECD, an ECD of X pounds per gallon seems to cause losses. So let's engineer our drilling program underneath that. Now I have a new sort of technical limit I didn't know before.
Right.
So I think those things can really provide some insight for the next one around. I've done that a ton with cementing challenges, where we had losses on the cement job. There were some other issues, and it was, okay, when did we first see the losses? Was it what part of the spacer or slurry was in the annulus?
Yeah.
What was my circulating pressure at that time? Or was it circulating before we pumped cement? Like when did it happen, and could we engineer our cementing program to stay below that? Because we were obviously able to drill the well, and just sort of back calculating our way into a technical window that we can get the job done without those problems.
Yeah. No, there's definitely, again, kind of just going back to the use cases, this stuff is, you can use it in sort of different scenarios, and clearly we've outlined it, but, I would say for someone who's kind of new and starting off on the hydraulic modeling, I think the troubleshooting piece is extremely important. I've seen, and even, myself, when I started running it as like just a young tech, a lot of times I would send out reports, not really, I would trust that I was doing the right thing, but then someone, internally would be like, whoa, did you notice this number? Like, we can't send this off. And so, the model, I guess the programs are certainly not dummy proof. Like, you can put some really wonky stuff in there and it'll just do the math and spit it out. Like, it doesn't really care what the output is. It's just going to do the math based on what you put into it. So, I would just be very careful, when running this type of stuff, making sure, like you said, someone, has verified and kind of, looked at the output, because you don't know where this report may end up. And if there's a decision made based off of it, and they're just assuming that what you put in there is correct, then, you may be having to explain a lot at some point, but, hopefully not, but just something to keep in mind. Really, that's all the questions, Matt, I had on the whole hydraulics modeling topic, but anything else?
I guess I failed to mention, just some of the features that you can go through, right? Like, there are some that will model like bed accumulation, and so obviously you hope to not see bed accumulation. But the interesting thing is, if you align those things, you'll see, wow, in like my build section, I'm most likely to have cuttings accumulate,
Right.
or the minimum flow rate that I need to clean the hole. Like, that can be a parameter relative to different ROPs, but normally the minimum flow rate is going to be highest in the area that's the hardest to clean, which is the build section.
Yeah.
You can do these other different things to sort of, parameters, and change them. Like, what is 50 RPMs versus 100 RPMs, or 350 versus 450 feet an hour, and sort of play with those scenarios and say, okay, are there any technical limits here?
Mhm.
Or when do I start reaching them?
Yeah.
So uh, hydraulics, there's a lot of features, and then I would say, besides the sort of obvious things, think through that information and what it's giving you, because there's also a chance that it can, without explicitly, like on a screen, show you some scenario, you might be able to sort of jigger together your own scenario through those features. It just requires a little bit of ingenuity.
Right.
But you'd be surprised at what you can come up with that goes beyond just your run of the mill. Here's my ECD at the shoe.
Yeah.
Those kinds of things.
That's a good point. I didn't really touch on like what the different outputs and examples for that. We had we were on a drilling in an area for a customer who was really trying to fine tune their ROP, mud weight, and flow rate, and because all those are variable, right? And are easily controlled. And we actually ended up kind of in an interesting scenario by pumping. So we were the typical issue was just having losses. And so of course the higher the ROP, the more cuttings load, okay, induced losses. Okay, mud weight, induced losses, pump rate, induced losses. Well, what we found was by reducing ROP by a certain amount, increasing flow rate by a certain amount, and then adjusting the mud weight, we built a model that had different variables, and we played with it at the rig, and we actually ended up optimizing their drilling parameters by the hydraulic modeling, and actually increased performance. And then they actually presented that information at an AEDE conference, and so on and so forth. And so it can really go a long ways. And so just a small example of different modeling, different inputs, and really working with an operator to enhance the drilling parameters and performance can really be a huge step in the right direction when it comes to just drilling efficiencies.
Absolutely. I mean, you get these models bang on. I mean, there are stories. I remember, working in the Gulf of Mexico where they had a PWD tool, so they actually had downhole pressures, and it didn't match the hydraulics, and the customer pulled the PWD. They were so confident in the hydraulic model, and it was, they were right, but the model was dialed into within about 100 psi of all the fluid behavior. I mean, they were that dialed in. So
that's a cool story.
These things have come a long way, and I'd encourage everybody to get familiar with these things. And use them. And the hard part in unconventionals is we have a lot of copy paste, and so there's a real risk of using it once and forgetting about it. But when you have this stuff all set up on all your wells, real quick, when a problem comes up, phone rings in the middle of the night, you can do a couple of runs, and it's not that painful.
That's so true. And with that being said, folks, if you have any other questions, you can reach us on LinkedIn. Matt and I are on there, or you can hit us up at the Flowline podcast at aesfluids.com. If you have any topics that you'd like us to cover, any ideas for a show, some of the best episodes come from folks reaching out and asking questions. Be sure to check out the YouTube page, check out the website, and overall, just appreciate all the support. And until next time, folks, take care.
Take care.
Thanks for listening. Please tune in next week for another exciting episode of the Flowline. And remember, may your returns always be full and your trips always smooth. Views expressed in this program belong to participants and not their employees. The program is for informational purposes only and cannot take the place of seeking professional advice. Copyright AES Drilling Fluids.